Good morning, sir. I am Harshit from 3rd ECE department. Today's my topic is Introduction to Basic DAC and ADC Techniques. And my roll number is 234g1a0443. Introduction of Basic DAC and ADC Technique. And what is meant by DAC means Digital to Analog Converter and Analog to Digital Converter. Introduction to DAC and ADC Techniques. Digital to analog converters (DACs) converts digital signals into analog voltages or currents. Analog to digital converters, that means ADCs, convert analog signals into digital data for processing. These converters are essential in modern electronic systems for communication, control and measurement. Basic principles of DACs, digital to analog converters. DACs generate a continuous analog output based on discrete digital input values. The most common types include binary weighted R2R ladder and sigma delta DACs. Accuracy, resolution and speed are key performance parameters for DACs. Basic principles of ADCs. ADCs sample an analog input signal at discrete time intervals to produce a digital output. Types of ADCs include flash, successive approximation, and sigma and delta. Pipeline ADCs. The accuracy of an ADC is determined by its resolution and sampling rate and linearity. Binary weighted DAC technique. Binary weighted DAC technique uses weighted resistors corresponding to each bit of the digital input. It produces an analog voltage proportional to the weighted sum of the bits. Suitable for low resolution applications due to resistor matching challenges. And binary weighted technique is very suitable for low resolution. R2R ladder DAC technique. Already we know the DAC, digital to analog converter technique. It uses a repetitive R2R resistor network for simplicity and accuracy. And R2R ladder DAC technique converts digital signals into an analog voltage with high precision. Widely used because of its scalability and ease of implementation. Successive approximation ADC technique. In successive approximation ADC technique employs a comparator and a digital to analog converter to iteratively approximate the input signal, finds the closest digital value to the analog input through a binary search process, and it offers a good balance of speed and resolution for many applications. Sigma delta ADC technique oversamples that the input signal and uses noise shaping for high resolution conversion, converts the analog signal into a high frequency digital bit stream, and the ideal for audio and high precision measurement applications. Key performance parameters. Resolution determines the smallest detectable change in the signal. Sampling rate affects how quickly the converter can process signals. Literally impacts the accuracy of digital output relative to the input. Applications of DAC and ADC techniques. Here is the both applications like used in audio systems, data acquisition and instrumentation. Critical in control systems and DSP, digital signal processing. Enable interface between digital processors and real-world analog signals. Here is the conclusion for DAC and ADC techniques. Understanding basic DAC and ADC techniques is a fundamental. Choosing the appropriate converter depends on the application requirements such as speed and accuracy. Advancements continue to improve the performance and integration of these conversion techniques. Thank you, sir.